Hello, everyone. So this week we're going to be covering quality assurance and quality control, which can be found in Chapter 11 of your registry review book. Okay, so first we're going to talk about quality assurance. So what is QA? So quality assurance or continuous quality improvement, abbreviated by CQI, includes the total overall management of actions taken to consistently provide high image quality in the radiology department, with the primary objective being to enhance patient care. Whereas quality control is going to involve the actual testing that we do to ensure that those standards of the quality assurance program are met. So you can think of it as quality assurance is the big umbrella, whereas quality control are going to be the actions and tests that you do that fall under that quality assurance umbrella. Okay, so all quality control programs have a few basic elements. So, what are some of the benefits of continuous quality improvement? Well, it results in a reduction of unnecessary radiation to the patient by reducing repeats. It helps to improve the overall efficiency of service, improved patient satisfaction. Consistency of image production is a big one because we want to continuously produce the same quality mammograms over and over again. And then lastly, cost effectiveness. When you're performing quality control tests and ensuring that your equipment is working properly, that is going to be the most cost effective way to maintain your operations. So, what are some of the agencies that play a role in quality assurance and quality control? So, state agencies help to define rules to protect the health and safety of the patients or clients served by healthcare facilities, whereas federal agencies such as OSHA or EPA. OSHA is a federal agency that establishes standards for safety in the workplace, whereas the EPA and the Food and Drug Administration are going to monitor matters ranging from bloodborne pathogens to the disposal of processing chemicals. Some more federal agencies. We have the National Center for Devices and Radiological Health, CDRH. This was formerly called the Bureau of Radiation Health. There's also the Nuclear Regulatory Commission, or the NRC, which serves to protect the public's health and safety, and also the environment from the effects of radiation from nuclear reactors, materials, and waste facilities. Then you have the Centers for Disease Control and Prevention, the CDC, and they are recognized as the main federal agency ensuring the protection, health, and safety of people both at home and at work. Some of the professional agencies and societies that are common within medical imaging is first the ACR, the American College of Radiology. They provide certification of the administrative, professional, and technical aspects of mammography services. Then you have the ART, which is the American Registry of Radiologic Technologists. They are dedicated to promoting the standards of education of radiographers entering the profession. Then you have the ASRT, which is the American Society of Radiologic Technologists. This is going to be the largest national professional association for technologists in radiologic science. Then you have the ARMRIT, which is the American Registry of Magnetic Resonance Imaging Technologists. They are a certifying organization that promotes formal MRI education with MRI clinical training. Then you have the ARDMS, which is the American Registry of Diagnostic Medical Sonographers. They are an independent, not-for-profit organization that administers examinations and awards credentials in medical, cardiac, and vascular ultrasound technology. Then you have JCAHO, which is the Joint Commission on Accreditation of Healthcare Organizations. They help to regulate the quality of care provided to patients and the way the facility is supervised and operated. Then lastly, we have JCERT, which is the Joint Review Committee on Education and Radiologic Technology. They are recognized by the U.S. Department of Education to accredit educational programs in radiography and radiation therapy. So beginning the QA process with the radiologist. So the FDA's MQSA regulation recommends that a lead physician should be responsible for general oversight of the MQSA quality assurance program. It is the responsibility of the lead physician to ensure that all individuals' qualifications and performance and assignments are adequate. The lead interpreting radiologist, in addition to the interpreting the images, the lead radiologist is ultimately responsible for quality imaging and an effective QA program. So as a mammographer, you will work closely with radiologists, medical physicists, your lead tech. You are all a team in ensuring that a QA program is effective. So, in addition to the interpreting the images, the interpreting radiologist should take corrective action in cases of poor image quality. They should participate in a medical outcomes audit as per MQSA. And they must also document current qualifications as per MQSA and local state laws. Now, the mammography technologist, they are going to be responsible for patient positioning, compression, and image production. The technologist plays a crucial role in quality control and is usually solely responsible for the day-to-day testing details. Now, the patient care responsibilities of the technologist include patient positioning, compression, image production, image processing after those images have been taken, and also ensuring infection control practices are being followed. Now, the medical physicist is going to perform annual evaluations of the mammographic unit and reviews all test procedures, including records, charts, and mammography policies and procedures on a yearly basis. And these are some examples of the digital mammography quality control tests that we have to perform as technologists. So the first one is going to be an ACR digital mammography phantom image quality check. This is to be done on a weekly basis, and if it fails, the corrective action is you have to redo it before clinical use. Okay, same thing goes for the computed mammography PSP erasure. This is only if applicable, of course, if you're using PSP plates. This is to be done weekly. If it fails, you have to correct it before clinical use. The third test we perform as technologists is the compression thickness indicator. This test is performed on a monthly frequency, and if it fails, it has to be corrected within 30 days. Visual checklist critical items. This test is again done monthly, and if it fails, you must correct it. Serious items need to be corrected before clinical use. Less critical items need to be elevated to your radiologist and your physicist within 30 days. And then number 5, you have your acquisition workstation monitor QC. This is performed monthly. If it fails, it needs to be corrected within 30 days and before clinical use for severe defects. Number 6 is the radiologist workstation monitor QC. This is to be done monthly. If it fails, it needs to be corrected within 30 days or before clinical use for severe defects. If your department has a film printer, you need to perform QC on that on a monthly basis, and if it fails, you need to fix it before clinical use. Same thing goes for view box cleanliness. So if you have view boxes in the radiologist reading room, you need to perform QC on those monthly. If they fail, you need to fix them before clinical use. A facility QC review is done quarterly. And then on a semi-annual basis, you will complete a compression force test. If this fails, it does need to be corrected before clinical use. Number 11 is going to be calibration. So this is going to be based on a recommended basis. You also have an optional repeat analysis. This is going to be done as needed and then within 30 days after the analysis if it's high. Also, system QC for the radiologist will be performed as needed if it fails within 30 days before clinical use for severe artifacts. And then also you have your radiologist image quality feedback. This will be performed as needed and there are no corrective actions. So as you can see, we are responsible for a very good amount of QC. It's really important that while performing QC, you stay organized, you follow the instructions in the manual. And if anything fails, of course, always try to retest and then elevate through your chain of command as needed. So as you can see, we are responsible for a very good amount of QC. It's really important that while performing QC, you stay organized, you follow the instructions in the manual. And if anything fails, of course, always try to retest and then elevate through your chain of command as needed. Okay, so next we're going to talk about the digital mammography quality control test performed by the physicists. So the first one is going to be the mammography equipment evaluation, or the MEE. So this is going to be performed when the machine is installed, and if it fails, of course, you can't use it until it passes. Same thing for the ACR digital mammography phantom image quality. This is going to be done upon equipment installation and annually. Spatial resolution, same thing, upon installation and annually. Same goes for the automatic exposure control system performance. If that fails, it needs to be corrected within 30 days. The average glandular dose test will be performed upon installation and annually, must be fixed before clinical use if it fails. Continuing on with physicist tests, you have the unit checklist, the computed mammography if applicable, acquisition workstation monitor QC, and radiologist workstation monitor QC. All of those have to be performed upon installation and on an annual basis. Any critical items need to be fixed before clinical use. Less critical items can be fixed within 30 days. Film printer QC, same thing upon installation and annually. If anything is not working properly before clinical use, it needs to be corrected. Also, evaluation of site technologist QC program, evaluation of the display device technologist QC program, and then any troubleshooting having to do with beam quality, half value layer assessment. All of those are going to be done on an annual basis. All right, so KVP accuracy and reproducibility, collimation assessment. Those are going to be both done upon installation and also anytime you're trying to troubleshoot a problem. Ghost image evaluation, view box luminance. These are going to be tests that are going to be performed if something in the department goes awry, okay? Okay, so then that brings us to the ACR Digital Mammography QC Manual. So, starting in 2017, the FDA approved the use of the new ACR Digital Mammography QC Manual for digital mammography 2D systems. Facilities with tomosynthesis or contrast enhancement equipment must follow all manufacturers' quality control guidelines for both the digital mammography application as well as the advanced technology application of their system. So this includes the daily tests. So daily tests must be performed at approximately the same time each day, but it must be performed before taking any clinical images. So typically your daily tests, you're going to have a daily QC tech who comes in a little bit earlier than everybody else, who will perform these tests at the same time every day. Weekly tests must be performed each week, but they do not necessarily have to be performed on the same day of each week. So, for example, if Friday was a holiday and your clinic was going to be closed that day, you could perform weekly QC on that Thursday. Then you have quarterly tests, which must be performed 4 times per year. The 4 months chosen must be spaced 3 months apart. These do not necessarily have to be performed on the same day of those selected months. Then you have semi-annual tests, so these must be performed 2 times a year. The 2 months chosen must be spaced 6 months apart. Once again, they don't necessarily have to be performed on the same day of those selected months. Okay, so for digital mammography, the general tech QC test. So daily, you're going to do monitor cleaning and workstation viewing and viewing conditions. Okay, then on a weekly basis, you're going to do your flat field test for the detector. You are going to do a modulation transfer function test, or an MTF test. You will do a contrast to noise ratio, or CNR measurement. You will do an artifact evaluation of detector and or printer. You will do a SMPTE, which is an SMPTE and or compression indicator test. Those include communication tests between the acquisition workstation and your detector/printer. You will also do a phantom image check. And the phantom image check. So this is an example of an older ACR phantom, okay? The schematic diagram on the right is going to show the relative position of the different objects that were embedded within the phantom. So you can't see all of these as clear within the phantom, but this is what it would look like, okay? So you have a total of 6 fibers, as depicted here. You have a total of 5 spect groups, so 1, 2, 3, 4, 5, and then you have 5 masses, 1, 2, 3, 4, 5. And you basically take an x-ray of this phantom and you try to determine how many fibers can you see, how many specks, and how many masses. And then there's a threshold in which it's passing. Now, some of the monthly tests you're going to do is going to be an automatic optimization of parameters, an AOP mode check. You will do a signal to noise ratio check and a visual checklist. On a quarterly basis, you will run a repeat analysis. Semi-annually, you will complete a compression force test. Now, for the medical physicist, these are going to be the tests that are performed annually. Okay, so once a year. They will evaluate the mammographic unit. They're going to review all tests, records, and charts. They will review mammography policies and procedures, and they will provide a written report of corrective recommendations for the radiologist and the mammographers. Now, some of these digital QC tests that the medical physicist will perform include a mammography equipment evaluation, flat field test, phantom image quality test that includes the acquisition workstation, radiologist workstation, and the printer. They will do a SMPTE pattern on the radiologist workstation, CNR and MTF measurement, an AOP mode and SNR check, a collimation assessment decompression, which is a compression release, ensuring that the paddle will release when you are done exposing, a breast entrance exposure calculation, an average glandular dose calculation. They will evaluate the focal spot. They will do an HVL or half value layer measurement. They will do a KVP accuracy and reproducibility test, exposure reproducibility, artifact evaluation. They will look at the viewing conditions and settings on the radiologist workstation. They will monitor the calibration checks on the radiologist workstation. They will do a screen uniformity test and then also laser printer QC. So as you can see, being a medical physicist in mammography, there's tons and tons and tons of tests that they have to come and perform. And that is why it's so heavily regulated. Now, when it comes to the phantom test, know that there is a new ACR digital mammography phantom, which we're going to go over right now. So the purpose of this phantom is to ensure consistent image quality and artifact-free imaging. So the frequency in which you have to perform this test is going to be weekly and after any service and before clinical use or on installation of new equipment. So the equipment needed to perform this test will be the ACR digital mammography phantom. Facilities may not use the old ACR Phantom with these new tests or the new ACR digital mammography Phantom with the old test. And then this is an example of what it looks like. So it's more rectangular in shape. It has a total of 6 fibers, 6 spec groups, and 6 masses. Now for phantom scoring. So the new ACR Phantom now has 6 fibers, 6 spec groups, and 6 masses. The Phantom represents a 4.2 centimeter thick compressed breast that consists of 50% glandular and 50% adipose tissue. The Phantom is designed to cover the majority of the digital detector area and provides the same attenuation as the previous screen film Phantom. Now, the final score of each test object in the new ACR digital mammography Phantom must be a fiber score of 2 or more, a spec group score of 3 or more, and a mass score of 2 or more. So at a bare minimum, that is what you should be able to visualize during your weekly checks. And a repeat failure must be corrected before clinical use. So this is a schematic diagram showing where to measure background optical density, cavity optical density, and Dmax. Okay, so these are all tests that the medical physicist will measure. You, as the mammographer, are going to complete the Phantom test itself. Okay, so computed mammography PSP erasures. So the purpose of this, the purpose of erasing the IP is to make it free from information that would affect image quality. So this must be done weekly, and you must do it for all computed mammography imaging plates. Now, IPs that cannot pass the test must be pulled from service and the problem investigated. The IP must be repaired before it can be used again. And when putting an IP back into service, you have to document the date and the type of service that was performed. Now we're at compression thickness indicator. So this test is to ensure that the compression thickness indicates the correct degree of compression. The frequency in which you will perform this test will be monthly and on installation of new equipment and whenever the indicator is suspected to be wrong. Now the equipment needed for this test will be an object to use as a phantom. It must have a known thickness. So for example, a 2-inch roll of medical tape, a ruler. You must also use a ruler with millimeter and centimeter scale, and you have to use a compression thickness indicator form. Now, note that the thickness indicator should be accurate to within plus or minus 0.5 centimeters or 5 millimeters. And if the test fails on a repeat, the source of the problem must be identified and corrective action taken within 30 days. So this is an example of what that would look like. So this looks like medical tape here. The compression thickness indicator test showing a tape used as a phantom. So basically the machine is going to measure what is the distance from the paddle to the detector and how well does that correlate to the actual size of the material that you placed underneath there. Then we have our visual checklist. This is to ensure that all indicator light, detents, and mechanical locks are in proper working order. This is to be completed weekly after any service and before clinical use or on installation of new equipment. Now, the equipment needed to perform this is just the visual checklist form. Any results, critical items must be repaired or replaced before clinical use. Non-critical items must be repaired or replaced within 30 days of a report of defect or damage. Okay, so visual checklist results. So critical items would include a cleaning solution available and all locks must work correctly. No cracked or defects on paddles, face shields, or breast support. The image plate holder for computed mammography units must hold and lock the IP properly, and the IP must be free of defects. Computed mammography IP should load into the CM reader smoothly. Whereas non-critical items, all equipment in the room, including the magnification stands and extra paddles, must be free from dust. Indicator and collimator lights must be working. No cracks on cables. CR motion must be smooth. And the compression paddle motion must be smooth. Now that brings us to the acquisition workstation monitor. So the purpose of this test is to ensure that monitors are free of dirt and dust or other marks that can interfere with clinical information. This test also checks the manufacturer specification and calibrations, including the brightness and contrast settings. The frequency that this test should be performed is monthly, after any service, before clinical use, or on installation of new equipment. The equipment needed will be a soft, dry, lint-free cloth or cleaning material recommended by the manufacturer. All failures must be corrected within 30 days. This is an example of the acquisition workstation. So you're just ensuring that these screens that you reference are clean, in good working order, and they have optimal brightness. This is an example of a SMPTE test pattern. So these are going to be tests that you run on the radiologist workstation. And basically you follow a manual to complete these tests, but you're assessing that, different shades of gray are visible on the computer. You can differentiate squares from rectangles. It assesses a variety of different things on their monitors. All right, so the purpose is to ensure that the monitors are free of dirt and dust or other marks that can interfere with clinical information. This test also checks the manufacturer's specification and calibrations, including the brightness and contrast settings. Now, you should be completing this test on a monthly basis after any service and before clinical use or on installation of new equipment. This monitor should also be cleaned if significant dirt or dust is noted during daily use. Once again, equipment needed is a soft, dry, lint-free cloth or cleaning material as recommended by the manufacturer. Any failures must be corrected within 30 days. Blemishes and anything interfering with visualization of the image must be corrected before clinical use. Okay, film printer, if applicable. The purpose of this QC test is to ensure adequate and consistent image quality on printed images provided to physicians, patients, and others. You must perform this test on a monthly basis after any service and before images are printed. This test is not necessary if printed images are not used. The facility should document in the QC logs if printed images are not used clinically. The equipment needed to do this test is a digital mammography phantom, a densitometer, and a film printer QC form. Clinically significant artifacts must be corrected before printing patient images. All failures must be corrected before clinical use. This is an example of a KDAC dry-view laser printer. So they come in a variety of shapes and sizes, and these would be the types of printers you would perform that film QC test on. Then you have your facility QC review. So the purpose of this test will ensure that the lead interpreting radiologist and facility manager are aware of all QC tests and their frequencies. The data from QC tests must be collected at the appropriate intervals, the results recorded, and corrective action taken. This test also ensures that clinical exams are conducted only when the imaging system is optimized. This facility review will occur quarterly or more frequently if problems are noted. Now, note that the equipment needed for this will be facility QC forms and data, and then the facility QC review form. If tests are not being done appropriately, or if corrective actions are not implemented or documented as required, the reason must be determined and appropriate action taken. So once again, it's really important that whoever is doing QC on a frequent basis, be very organized so that when you get to this facility QC review, everything is in order. Then you have your compression force test. So this is a check to ensure that sufficient force is applied by the hands-free initial power drive mode and that adequate compression can be maintained throughout the image acquisition. Now, the test also ensures that the system provides adequate manual fine adjustment. The frequency of this test is going to be biannually or every 6 months. If unstable compression is suspected after any service and before clinical use, or on installation of new equipment. So the equipment needed for the compression force test will be several towels, and you're going to use the towels and fold them to protect the detector. And then you need a calibrated analog bathroom scale. Digital scales often do not respond properly when added pressure is applied and are not recommended. Digital gauges or compression force tools may also be used. And then you need your compression force form to record the results. So this is an example. So you place towels on the detector, and then you kind of sandwich the bathroom scale in between your towels. And basically you use a compression force of at least 25 pounds must be provided for the initial power drive and for the manual mode. The force must be maintained for the time it takes to make an average exposure. And for the initial power drive, the maximum compression force should not exceed 45 pounds. If the test fails, the problem must be corrected before any examinations are performed. Then you have your repeat analysis. So the repeat analysis will determine the number and cause of repeats. The test is performed to help identify problems with the equipment, improve efficiency, and reduce patient exposures. So for frequency, for a meaningful repeat rate, this test should be performed with a minimum of 250 patients. The equipment needed is going to be data on all repeats, a method of counting those patient exposures, and then the repeat analysis form. Now, note that some equipment types have a built-in automated system to collect, record, and analyze the repeated clinical images, which is becoming more and more common in today's technology. Now, how do you calculate a repeat rate? So the total percentage of repeats is going to be the total number of repeat exposures over the total number of exposures times 100. Whereas if you're trying to figure out, once you narrow it down to your repeats, if you're trying to figure out, okay, what's the percentage of repeats due to positioning or technique, different reasons, the percent of causal repeats will be the number of repeat exposures in a specific category divided by the total number of repeat exposures times 100. Now, the overall repeat rate ideally should not exceed 2%, but a rate of 5% is acceptable. And it's really important when you get new techs into the department that you run a repeat rate somewhat frequently to ensure that the techs are getting better with positioning, getting more comfortable with the equipment so that you can reduce your patient dose as much as possible. Okay, then you have your system QC for the radiologist. So the purpose of this is to allow the radiologist to perform a quick check of relevant QC tests, in particular the detector and monitor test. This test is optional and performed as needed, and the equipment needed will be the system QC form for the radiologist. If any image quality program is identified, corrective action must be taken. Now, the feedback from the radiologist image quality test. This test ensures that the radiologist provides feedback on image quality to the technologist. Once again, it's an optional test that is performed as needed. The equipment needed will be the radiologist image quality feedback form. If there is severe deficiency in image quality, the patient should be called back for additional images. Okay, then that brings us to physicist tests. So the medical physicist is required to conduct a mammography equipment evaluation of new equipment and after major repairs and conduction of an annual test. The medical physicist should also perform an annual survey on each unit. 14 months between surveys is acceptable. And some of those tests are going to include a compression paddle deflection, X-ray beam limiting device illumination, signal to noise ratio and CNR, spatial resolution, automatic exposure control, average glandular dose, a unit checklist. Test for the computed mammography systems include acquisition workstation and radiologist workstation monitor QC, film printer QC, evaluation of the site's technologist QC program, beam quality including half value layer, KVP accuracy and reproducibility, collimation assessment, manufacturer detector calibration if applicable, ghost image evaluation, and then lastly, view box luminance. Okay, so all in all, QC is a big part of mammography. It's important to stay organized, to follow the manuals, and to keep a timeline on when you need to perform said tests so that you can always pass all of your inspections. And that is all I have for you.